What are the properties of logarithms that we need to know about and need to know how to manipulate? So we're talking here by the end, we're going to hopefully be able to evaluate expressions involving the logarithms and then solve the equations and inequalities using logarithms. We're really going to stick with equations in pre-calculus this year. Inequalities really have the same rules applied to them as the equations, and we just have decided to stay to equations. So our big properties here, we have 4 properties. 3 of them I think require memorization. One of them kind of just always has made sense to me, and so I don't feel like I ever have to like remember it. It just kind of, when I see it, it makes sense. But the first 3, the first one says, okay, we can go in between when you have a logarithm, multiplication and addition. In other words, the log of a value plus the log of another value is the same thing as the log of that value, 2 values multiplied together. Another one is that division can go in between subtraction, all right? It can be interchanged with subtraction, or we can kind of go back and forth with subtraction. So when you're subtracting them, you have a value subtracted another value that you can change it into here into division. The next one is that an exponent is interchangeable, or can be kind of changed around, rearranged as a coefficient. Alright, so you can have a value be the coefficient, and it can move down and it can be the exponent. And then we can have a value be an coefficient and move up and be the exponent again. So exponents can become coefficients, and coefficients can become exponents. The last one says, okay, when we have 2 logs and they have the same base and they equal each other, alright, that we can ignore the fact that we have the log at all, and then that just our values would be equal to each other. And that kind of, again, this is the one that kind of just makes sense to me. Like, oh, okay, I can get this. It makes sense. It's logical to me that if the log of something equals the log of something else, those 2 values have to be equal. So let's look at some example problems. The first one I notice here with log base b of 64 raised to the 1/3 power equals 1/3 is that we have an exponent here. And our rule says that their exponents can be and can become a coefficient. So that's the first thing I'm going to do. I'm going to make that 1/3 the coefficient of log base b of 64, and have that equal to 1/3. Then to deal with the 1/3 out in front, I'm going to multiply both the right and the left side of my equation by 3/1, the reciprocal of that 1/3, and that becomes just a 1. So what we have here is we have log base b of 64 equals 1. Now if I put it in exponential form, it's b to the first equals 64, which then tells me, well, then b must be a 64, because only 64 to the first power equals 64. Let's look at our next example. Our next example is one where we have log base 10 of 2x plus 5 equals log base 10 of 5x minus 4. Well, if they're both log base 10, we can basically ignore that they're there in the first place. We can say then that must mean that 2x plus 5 has to equal 5x minus 4. Then I can go through and subtract 2x from both sides, add 4 to both sides, and divide by 3 on both sides. So I can figure out for this problem x must equal 3. Let's do another one. Now we have addition, alright, and we have a log base 11 of x plus a log base 11 of x plus 1 equals log base 11 of 6. Well, addition, if you remember, is interchangeable with multiplication. So I'm going to say log base 11 of x times that x plus 1. So what I did here is I took what was I had separate logs, and I kind of condensed it. I condensed it into one log, and that's going to equal log base 11 of 6. So here, this log base 11 and this log base 11 essentially cancel each other out. And so I have x times x plus 1 equals 6, or x squared plus x equals 6. Now to solve this, when we have a quadratic, we're going to need to first set it equal to 0. So I'm going to make it x squared plus x minus 6 equals 0. Now we need to factor. So we're going to need to factor the left side of our equation. And I'm going to think, what 2 numbers multiply to give me a negative 6 and add to give me a positive 1? The answer would be positive 3 and negative 2. So x can equal a negative 3 and x can equal a positive 2. Those are my answers. Next example here. We have the log base 3 of 4x minus 5 minus the log base 3 of 3 minus 2x, and it equals 2. So now I'm going to change this subtraction into division. So I'm going to write it as the log base 3, and then I'm going to have the 4x plus 5 as a numerator, and the 3 minus 2x is my denominator. And now that equals 2. Now I don't have a log base 3 equals a log base 3, I just have the 1. So what I can do now is I can change it into exponential form. I can say what we really have is 3 to the second power must equal this 4x plus 5 over 3 minus 2x. Alright, so that whole grouping. And 3 to the second power is really 8. And I'm going to think of it as 8 over 1 equals 4x plus 5. And I'm just kind of recopying this 3 minus 2x. And what I can do now is I can do kind of cross multiplication. I can say, hey, these two multiplied across each other will equal the other side, the other way 2 multiplied across. I'm going to kind of come up here to solve this. And so what I get is 8 times the 3, or 24, minus 16x. All right, so I multiplied the 3 and the minus 2x by 8, must equal, and I'm running out of space here, by 4x plus 5. I'm sorry, I ran out of space. So if I added 16 to both sides, I'd get 20x here plus 5. If I subtracted 5 from both sides, I'd get 19 equals 20x. And then if I divide both sides by 20, x would equal 1920. All right? So I think I'm trying to decide if I have everything correct. 16, add the 16, 20. Yep, I'm doing fine. 4x plus 5. All right.